Good morning, all of you. Myself, Dr. Ruchi Gupta. Today, I will discuss the topic data link layer, which is the next second bottom layer of OSI reference model. I have already discussed the OSI reference model in detail in my previous lectures. So, this is the second bottom layer of OSI reference model. So, today I will discuss the functionality of this data link layer. So, basically the data link layer have two main functionality. First, it provide us a framing facility, as well as the second main functionality of data link layer is a flow control and error control. So, the major functionality of data link layer is a framing and flow and error control. And we have to use two main devices at the data link layer. The first one is a switch and second one is a bridge. So, these are the basic functions of data link layer. So, data link layer, it will provide a well-defined services interface to the network layer. Data link layer is a communication layer between the network layer and the physical layer. Network layer is the upper layer of DLL and the physical layer is the bottom layer of the DLL. So, it will provide the interface. It is an interface between the network layer and the physical layer, or we can say that the data which is coming out from the network layer in the form of packet. So, the data link layer will convert these packet into the frames and then it will send these frames to the physical layer. Then physical layer will further divide it into the frames into the bits or the signals. So, this is the first function of DLL layer. Second, it also deals with the transmission error. So, if there is any error in the channel, so it will provide us the facility of find out the error in the network, and it will also reduce that error. Next, it will provide us the facility of the flow control. So, it will regulate the flow of data so that the slow receivers are not swept by the fast senders. Or we can say, if the sender is capable to send a large amount of data, but the receiver is not capable for receiving that amount of data, so there will be a overflow condition in the channel. So, it will provide us the facility of the flow control also. So, these are the major functionality of the data link layer. Now, data link layer is basically divided into two sub-layers. So, the first sub-layer is a logical link control or LLC, and the second sub-layer of DLL is media access control or a MAC. So, both sub-layers have a distinct functionality. So, if we are talking about the LLC, logical link control layer, so logical link control layer is responsible for framing, flow control and error correction. So, I will discuss the LLC as well as media access control layer in detail. So, and the next sub layer of DLL layer is a media access control layer. So, media access control layer is basically responsible for providing the channel or for allocation of the channel for the network, or it is a process, or it is responsible for providing a method for stations to gain access to the medium. So, I will also discuss this media access control layer in detail in my next lecture. So, the first, if we are talking about the LLC. So, the major functionality of logical link control is framing, because it provide the LLC layer is responsible for framing as well as for error control and the flow control. So, the framing, what is framing? As I have already told that the data which is coming out from the network layer, it is in the form of packets, and packets are nothing, these are just a collection of bytes or bits. So, when the packet will reach at the data link layer, suppose if packet is a 128-bit packet, and when it will reach at the data link layer, So, the data link layer will divide that packet into the number of frames. So, 128-bit packet can be divided into 64 bit of frames. So, it means the 128-bit packet is divided into 2 frames, or we can further divide into number of frames like 32. If we divide into 32 bit of frame, then 128-bit packet will divide into 4 frames, and if we divide into 64 bit of frame, then it will divide into 2 frame. So, the data link layer needs to pack bits into the frame. As I have told that the packets which we have received from the network layer is now converted into the frames. So, these bits converted into the frame, so that each frame is distinguishable from another. Means each and every frame have a distinguished number of bits. So, our postal system practices a type of framing. So, we can define it as a postal system, like we have sent the letter to the destination. So, the data is divided into the number of frames. So, the simple act of inserting a letter into an envelope, it separates one piece of information from another. So, because it's just like a postal system, we have just write some information into the letter, and we have to put that letter into a separate envelope, which is totally separate from another. So, the envelope serve as a delimiter. So, we can framing can be done in 2 ways. One is a fixed size framing and second one is a variable size framing. So, either we have to divide the whole frames into a fixed size of frame, whole data into a size of frame, or either we have divide the data packets into the variable length. So, this is a frame in a character oriented protocol. This is the method that how we can send the frame from source to destination. So, when we have to send the data from source to destination, so in that case we have to send 2 things. One is your data part and second one is your header part. So, header and flag, basically flag field it will use for header, it is used with the with your data part, and the data it may be a variable number of characters. So, variable number of characters may be transferred from source to destination. So, this is a complete header format of frame, which include a data part as well as at the header part. So, when we have to send the data, when we have to convert the data into the frames, then there is a need of white stuffing and unstuffing. So, first of all, when the data will reach from the data into the data link layer from the upper layer, that is a network layer. So, it will stuff that information. So, it is your header part which is included with your data part, and we add 2 or 3 more fields like trailer, header and trailer, that contains the information of source as well as destination as well as error or flow control, and we also add one more field, that is ECS. So, when the data, these are 2 extra byte which we have added on the header format of the frame. So, when your data, when your this frame will be received by the receiver, so the same format, the same header will be received by the receiver. Now, the 2 fields which we have, the 2 bit which we have stuffed in these at the sender side, it will first unstuff, these 2 bytes will unstuff, and after that it will receive by the receiver. So this is a completely unstuffed data which is received by the data link layer. So basically when we have to perform framing, then in framing we have performed some white stuffing and unstuffing method, so that our frames are to be correctly sent or received by the sent by the sender or received by the receiver. That's why there is a need of bit or byte stuffing. So what is definition of white stuffing, or what is the concept of white stuffing? So white stuffing is the process of adding one extra byte whenever there is a flag or escape character in the text. So we have just add one extra byte with the frame. When it will reaches to the destination, then this byte will be extract from the data part, and then actual frame will be received by the receiver. And basically the purpose of this adding stuffing, it is because we want actual data, we want to transfer the actual data from source to receiver. Second, we can also perform a bit stuffing. In a byte stuffing, we can add 8 bits together, but in a bit stuffing we have just add 1 bit. So bit stuffing is the process of adding one extra 0 whenever 5 consecutive 1 follows a 0 in the data. So in this bit stuffing process, we have add one extra 0 with the 5 ones, so that receiver does not mistake the pattern of that for a flag. So suppose we have 5 1 bit, 1 2 3 4 5, so we have just add 0 with this data, so that there will be no chance of any mistake. So this is the process of bit stuffing. So this is the process of bit stuffing and unstuffing. So the data, it is reached from the upper layer. This is our header part plus data part. It included both. So let me see what is exactly the data. So suppose here 0 0 0, then we count 1 2 3 4 5. So when we have to receive 5 ones in the data, so after just the 5th one, we have insert the 0 bit. This is a bit stuffing, so that there will be no chance of any mistake in the data. Now again we have read the data 1 1, then 0 0, again we have to receive 5 1 1 2 3 4 5. So again we have to insert 1 0 bit. So now after bit stuffing, we have to send this data frame to the destination. When data frame will receive by the destination part, then in this frame 2 bits are to be stuffed, 0 0. Now there is a need of unstuffing. So before receiving the actual data at the destination side, we will perform the unstuffing method. So again we have just count after 5 the 0, we have unstuffed that 0. Again we have to check the data. If again we have to receive 5 1 then 0, then we have to remove that 0. So finally the data is received in this actual form, which is sent by the source. This is our actual data which is sent by the source and it is received by the receiver. But in the middle of that, we have performed here stuffing, bit stuffing and byte stuffing process, bit stuffing and unstuffing process, so that there will be no chance of any mistake in that data. So this is the process of framing in the data link layer, and this is the major functionality of logical link control sublayer. Now, the next two major functionality of LLC is the flow control and error control. So, the most important responsibility of the data link layer are flow control and error control. Collectively, these functions are known as data link control. So, these two major functionality of data link layer or the LLC layer, that is flow control and error control. So, if we are talking about the flow control, what is flow control? Flow control refers to a set of procedure that is used to restrict the amount of data that the sender can send before waiting for an acknowledgement. So, what is the mean of this flow control? Flow control is the procedure that if the sender send the data, it send a bulk amount of data to the destination, and destination is not capable to receive a such amount of data. So, in that case, there will be a condition of overflow. So, we have to remove this condition of overflow with the help of flow control method. So, flow control method, it will restrict the amount of data. It means the sender will only send that amount of data that is exactly received by the receiver at that time, so that there will be no overflow condition will occur at the channel. So, the flow control, it is a set of procedure which is used to restrict the amount of data. It means we have to restrict that amount of data which is we have just for example, we have just sent 1 or 2 bit at a time, so that receiver can exactly receive that amount of data without any failure. So, that sender can send before waiting. So, in that case, sender will wait for the acknowledgement until the first frame will receive by the receiver. The sender will not send the next data or next frame. This is the concept of flow control. Now, the next major functionality of data link layer or the logical link control layer is the error control. So, error control in the data link layer, it is based upon an automatic repeat request, which is a retransmission of data. Suppose if there is any error in the channel, and for any reason, for any point of time, if your data is lost due to any reason, so in that case, the error control facility, with the help of this facility, we can retransmit the same data or same frame again, so that we can transmit the data actually by the source, and it can actually receive by the destination without any failure or without any error. So, with this process, it will use the automatic repeat request method, so that your data will be automatically resent to the or retransmit to the destination again, if for a amount of time, if we have not received the acknowledgement of the data. So, it means we can assume that the data is lost due to any reason. So, we can again retransmit that data. So, this is the process of error control. So, for at the logical link control layer, there are number of protocols have been worked out. So, now let us see that how the data link layer combine the framing, flow control and error control to achieve the delivery of data from one node to another. So, the protocols are normally implemented in a software for the various common programming languages to make discussion. It is a language free. We have to write down the various protocols which we are used at this layer. So, if we are talking about the protocols, there are two main protocols have been used. One is for the noiseless channel and second one for the noisy channel. So for the noiseless channel, we are using two main protocols. The first is a simplex protocol, second is a stop and wait protocol. And for the noisy channel, we will use three protocols: stop and wait, go back ARQ, and selective ARQ protocol. So the first protocol is a simplest protocol. So this is our sender side and this one is the receiver side. We have to send the data from source to destination. So in this is the case of simplex protocol with no flow and no error control. So in that case, there is no mechanism of any flow or error control. There is simple protocol. We have just sent the frames from sender to the receiver without assuming the overflow or error condition. So in that case, we have just sent the data frames, number of data frames to the destination, and we have sent the data. The receiver will receive that data frames in a sequence. We have just applied the algorithm at the sender side and algorithm for the receiver side. And the events occur. Event at the sender side is request from the network layer, and this is the event for the receiver side, which is notification from the network layer. So we have just the total number of frames without knowing the channel allocation capacity to the into the network. We have just sent the total number of frames from source to destination. This is a simplex method. Now in the simplex method, there is a drawback at this method, at this level of method, because our data is lost due to overflow condition or due to failure of the packet. So we have applied another mechanism, that is stop and wait protocol. So in this stop and wait protocol method, sender at a time send only one frame to the destination. So when it will reach to the destination, and once the receiver will receive that frame and it will send back the acknowledgement to the source. So until it get the response from the, response or acknowledgement from the receiver, it cannot send the next frame. So we can say in the stop and wait protocol, at a time only one frame is sent to the receiver, and after sending that frame, the sender will wait for the acknowledgement. So it will reduce the condition of overflow and error and the channel. Now the next, in the stop and wait, we use a sequence number. Like this is a stop and wait ARQ method. In this stop and wait ARQ method, we use sequence number to the number of frames. The sequence number, these are modulo 2 arithmetic. So we have just sent the number of frames in modulo 2 arithmetic. So this is the process of stop and wait ARQ protocol. We have just sent the frames to the sender, and the data frame, it will contain the sequence number, and acknowledgement frame will contain the acknowledgement number. So when the frame will send by the source, when it will send by the source, when it will receive by the receiver, receiver will send the acknowledgement of that frame, which is just received by the receiver. And with this frame, it contains two things. It is an acknowledgement frame, and acknowledgement number is attached with that frame. So this is an event request from the network layer. We will apply the algorithm for the sender side. If timeout, so if within a period of time, if we have not received that acknowledgement, then it means we can understand that our data or our frame is lost. So, at the receiver side, this is the algorithm for the receiver side and the notification from the physical layer. Similarly here, if timeout event occur, it means our data is not exactly received by the receiver. Next is the go back ARQ protocol. In this protocol, the sequence number are modulo of 2 to the power m. So, where m is the size of sequence number field in bits. So, this is the process of go back ARQ. In this go back ARQ method, we have just sent the number of frames to the destination. So, as the number of frames sent by the source and in the sequence and at what sequence it will receive by the receiver. So, suppose if receiver will receive the second frame first. So, the second frame response will send first. So, receiver and the source both are continuously send or receive the frames. So, in this case, because in stop and wait ARQ method, we have just wait until we have to receive an acknowledgement of the first frame. So, it is a very time consuming process. So, in that case, in the case of go back ARQ, we have make a sliding window. So, we have sent the total number of frames which is a number of which is the size of equal to the size of the sliding window, and the sliding window will slide automatically when we have to receive the acknowledgement of the frames. So, same thing happen here. Algorithm will for the sender side, notification from the physical layer. This is a timeout, and in the time within a time period, if we have not received the acknowledgement of the frame, then we will transmit the frame again. So, next is in selective repeat ARQ, the size of the sender and receiver window must be most half of 2 to the power n. So, in this case, in the selective repeat case, we have make a size of the window which is at most 1/2 of 2 to the power m. So, this is the design of selective repeat ARQ. In the selective repeat ARQ, this is our sender side and this is our receiver side. We have just sent the total number of packets, and when the packets are to be received, when these frames are received by the receiver, then receive will send the frame and it will contain. If we have to compare it with the previous method, which is a go back ARQ, in the go back ARQ method, the only acknowledgement field is add with the frame. But in this case, in the selective repeat ARQ, we have add two fields here. One is acknowledgement or negative acknowledgement. Either it will be a negative acknowledgement or positive. So, if data is exactly received by the receiver, so in that case, it will send the positive acknowledgement to the source, or if the data is not received by the receiver, so in that case, it also send the negative acknowledgement to the source. So, we can say that a source will wait for the acknowledgement, either that acknowledgement will be positive or negative. So, if your data is exactly received by the receiver, then it will be a positive acknowledgement, or if it is not exactly received by the receiver, so in that case it will send the negative acknowledgement to the source. So this is all about our protocols which we have used at the data link layer. Now, in my next lecture, I will discuss about the MAC layer of the DLL layer, which is a sub layer of data link layer. Thank you very much.